right, where do we begin? This story has part of its roots in Bulgaria. And what had happened was one of our clients had a hydrogen leak on some stator bars in their generator. And as they investigated the leak, they talked to the equipment manufacturers, and they were told that it wasn't that bad a leak, just keep topping it off and go ahead and run until their next scheduled outage. So when they finally got shut down and went in and investigated, they determined that the joints at the ends of the stator bars had failed, and the insurance company had some metallurgy performed, and the results were that it was crevice corrosion cracking. Well, I asked Nick to do some research on crevice corrosion cracking. We were sitting in basically a quarterly meeting where it was a get together to have everybody meet each other in different departments. Well, kind of bored with a lot of the hula hoop demonstrations, so I figured he'd rather do research. So he looked into it for me, crevice corrosion cracking. And to start with, it's a special kind of corrosion. We'll get to that more in a minute. But the insurers basically concluded that since the word corrosion was involved and the word cracking was involved, that this loss was going to not be covered by the policy. It was about a $3 million loss. And, we looked at it a different way. We pulled the thread a little bit deeper as to why was that crevice corrosion there. And to start with, one of the things that we were very fortunate as engineers, we have been brought up with in the insurance language world. So the group we work with writes manuscript policies, so we understand the wording and the differences in different wordings and different policies. So when we looked at the wording of our policy, we basically concluded that no, there was something else at play here. It wasn't just crevice corrosion cracking was excluded. And in our policy, we exclude normal corrosion. And that word normal, just that tiny little word, makes a huge difference. You won't see that in all policies. In fact, some policies say all corrosion, not normal corrosion. So the fact that ours said normal gave Nick and I an ability to pull the thread a little bit more. So if you look into crevice corrosion, in fact, it's a very unique and unusual type of corrosion. The conditions have to be just right. There has to be small places. The humidity has to be just right, and hence that's the name crevice corrosion. It doesn't just happen. The things need to come together before it can happen. So it's not something that would be considered just normal corrosion. So we think our policy is proper. The underwriters agreed because they took that wording. We looked at the fact that our crevice corrosion was not normal, and that the policy did not exclude this crevice corrosion. How did the crevice corrosion take place? Why did it form? Well, we learned that when the stator bars are put together, the heating process of bringing the copper up to temperature before putting in the alloy to make the connection, that creates a passivation layer, it's called, around the copper. And a passivation layer does what the word says. It passivates the metal. And you've seen it if you drive down the road and you see the brown light poles where there might be rust stains down on the concrete pedestal. That sacrificial layer on the outside is forming a passivation layer that stops all the rest of the corrosion from penetrating deeper where it can cause structural damage. So it sort of goes in just to the very surface and stops, and that's it. That's what's supposed to happen on these stator bars when you put them together. In the case of our friend, their leaks were basically because when the shipping of these stator bars took place, the ends were taped to protect them. And it's a procedure to, when you remove that tape, to use solvent to clean the ends of that tape, of that sticky stuff off of the copper endings. That wasn't done on some of these bars. And so leaving that step out basically allowed that heating process to heat up the glue and create a carbon layer. Well, once that carbon layer was in place, there was no way for a passivation layer to form. So that step was poor workmanship. And the poor workmanship is not going to be covered. They're not going to pay to redo that poor workmanship step. But the damage that occurred because of that, that is that condition that was right for crevice corrosion to occur, the formation of a crevice, because this weld or this fusion of this metal wasn't made properly. So that poor workmanship led to the damage that went down beyond. We actually brought in some international case law to back this argument up, and presented the underwriters with another opinion of the policy and coverage. And we were successful in our client, getting that $3 million claim paid.